So let me tell you, like, if it might not make sense to you guys if you haven't read the problem. So in project 3, we have a matrix model, and it's going to be a Leslie matrix model. And in that Leslie matrix model, what you need to find is like for the next couple of years, what should be the value of the components. So it's kind of like what you did for exam 2 problem 7. When I told you guys, hey, find the population after day 1, find the population after day 2. So something similar to that one. And to find that, what you have to use is like this, the first um, .m file, which is called eco succession table. So here, what you need to do is like, obviously, you have to probably write your name. I'll still upload uh, another smaller video, which will tell you more about this. Write your name here. Then after that, this is going to be a transfer matrix. So write this according to the one that's given in the problem. Then, as you can see, this is the initial population. Same as before, like read the problem, uh, modify these as the problem says, prompt. And then what you have is this. So you don't need to like modify these steps. But here, where you can see like T is 1, 2, 3, 4, 5, 6, 7, sorry, 5, 10, 20, 30, 40, 50. What this step is doing is like after 20 is 1, so say like after 1 year, what should be the value of the components or the population, however you like to remember. Then after T is after the second year, what should be the value of the components again? After 3 years, what should be the value of the components? After 4 years, what should be the value of the component? After 5 years, what should be the value of the component? Then it has like 10. So after 10 years, what should be the value of the components? 20, 30, 40, 100, 200. So after 200 years, what should be the value of the components? So if you run this, and you can see, so value of the components are given to you as a table, which is pretty good. Like after 1 year, these are the values. After 2 years, these are the values. After 3 years, these are the values. So you will have to modify this bit according, like the T, according to the number of years I'm asking you in the problem. And it will just give you what? It should just give you the value of the components. So it's pretty easy. Just like you can just write this in the report, or you can just screenshot from here and paste it in the report. Okay. Then what you have is, so this is the first bit, okay? There is like 4 bits. This is the first bit. So there's like 3 parts. This is the first part. Any questions for this? Okay, don't have any questions. Then what you can do is, let's look at the next one. Okay, so what this uh, um, .m file is doing is like, it will, if you feed it a matrix, which is this one, is the matrix. First of all, according to the problem, you will have to change the matrix. This is like a dummy matrix, okay? So this just says like 1, 4.5, and 0 matrix. So you'll have to change this for sure. So this .m file will give you eigenvalue, dominant eigenvalue, and the eigenvector. So all the things you're gonna need. So in that project, the last project we have, project 3, on the part B, it will tell you to find the dominant eigenvalue and the long-term structure, so the eigenvectors. So if I run this, you will see here. So it gives you the eigenvalues, it gives you the eigenvectors, okay? it gives you the dominant eigenvalue, and also it gives you the normalized eigenvector. Okay, so it literally gives you everything. So all you need to do is like change this matrix value here according to the problem, and from there you just write these values in the report. That's it. So I feel like this should be not that hard for you guys. It's just like modifying the matrix for this file and modifying the matrix and initial state for this one and the number of years. Any question for this project? Okay, so I'm telling you again, I will upload a short another video. If you guys forget what I told you to find when you're trying to solve it, you can like watch that video and solve it again. Okay, no questions, I guess. Okay, then let's. Okay, then let's start the probability. Okay, so we are in chapter 11. Okay, so what I'm gonna do is like we're gonna start with an example of what we're doing on Monday. So let's say consider the sample. You guys can see it, right? My iPad, hopefully. Can you see my iPad in your Zoom as I'm sharing it?
Yes.
Okay, thank you. Thank you. Space of. So what we're gonna do is like we're gonna consider a sample space of blood types and their RH factor. Okay. And I'm gonna say let E be an event and event of type B blood and A be the event of RH positive. So list the elementary events of E and F, then find E union F, E intersection F, not E, then E intersection, not F. Okay, so this is the problem we have. So first thing I'm gonna ask you guys, like, we need to have a sample space which has like the blood types at their RH vector. So what should be the sample space for this?
Like B positive or B negative.
Yeah, those ones. So do you know anything else? So just B is gonna be event E, right?
Mm-hmm.
What you said. But if I want to find the whole sample space, what should that be? We
It's
need the
gonna
whole
be like
sample.
A positive, A negative, A B positive, A B
Mhm.
negative, like
Yeah,
O negative, O positive.
exactly. So for the people who don't know, if we have a problem like this where we are talking about blood types and RH factor, the sample space would be A positive, A negative, then B positive, B negative, then AB positive, AB negative, then O positive, O negative. So that should be the whole sample space. And thank you, Artsy. And now what we are talking about at first, E is an event which only has blood type B, right? So E is B positive and B negative. Okay. Now, F is an event of Rh positive. So F is what? Let's ask someone. Emily, any idea? Are you there, Emily?
No, not
Hmm? Did you say something, Emily? Or okay, maybe not. Okay. Haley, any idea what should be F? Okay, anyone else?
Should
Alexis?
be B negative.
B negative. So F is what? F is all
So,
Rh positive. So it
so
just
it's
means
any, so
any
A
positive.
plus, B plus, AB plus, O plus.
Yes, yeah, yeah, exactly. Okay, so that's F. Now, if I want to find E union F, the first one. So for that, let's ask Ashley. Do you know how to find that, Ashley?
can you hear me?
Yeah, when you're finding the E union F, what should I do?
Would it be all,
Mhm.
all of B and all of F, that would be plus B minus A plus B plus AB plus and A plus?
Yes, exactly. Thank you. Thank you, Ashley. So it's going to be all the elements, right? So B plus, B negative, then A plus. So I don't need to write B plus again. As I was mentioning before, like if you have the same element once, that's it. You don't need to write it twice. So I'm not going to write B plus again. And AB plus and O positive. So that's going to be E union F. And E intersection F. What should that be? Do you know that, Ashley?
Yeah, I'm looking back at my notes.
So think about like, so intersection means like common ones, right?
Right.
So between E and F, what is the common element you have on which is like on both of them?
Oh, just B plus?
Just B plus, yeah, that's it. Okay. Now we need to find not E, okay? So not E means all the elements that is in the sample space S, but not in E, okay? So we're going to exclude these two, and we're going to take all the other elements from the sample space. So not E, I'm going to write it myself, A positive, A negative, AB positive, AB negative, O positive, O negative. Okay, so that's going to be not E. Okay, so last thing we have to find is E intersection F. E intersection F, this is the last one. So for E intersection F, at first we need to find F, not F, okay? So not F is, again, all the elements that's not in F, but in S, like the whole sample space. So we have A positive, so we don't need that. We need A negative, then B positive is there. We have B negative, then A B negative, then O negative. That is going to be F, not F, of or F complement. Okay. Then Okay. Oh, it's okay, Haley. It's okay. If you're on the quiet way, you don't have to say. You don't have to talk. Okay. Okay. So, um, E intersection F complement. Okay. So for this, all the elements that's like in E and also in F. So what should this be? The common elements.
B minus.
B negative. Yeah. Only B negative. Only B negative is in present on here and here. Okay. Okay. So that's it. This is the whole problem. Uh, okay. You guys are okay with it? I guess, hopefully. Okay. So now we're gonna start off with like with some couple of like properties, okay? So these are like new stuff. Still in chapter 11, but we're gonna talk about a couple. Yeah.
I have a quick question.
Yes, yeah. Yeah.
You said that was a blood type problem. Will we have to know and list all the blood types, or will it be given to us?
So if we are talking about blood types, these are the ones. Yeah. So you guys will need to know it.
Okay.
These are
Thank you.
all the types, nothing else.
Okay, sounds good.
Okay. Okay. Yeah. Okay. Good question though. So chapter 11, properties. So I'm going to talk about one new properties, and there will be like 4 of them. Okay. So now what we're going to do, we're going to think about where to find probabilities of these intersections, unions, or E minus F or not E. These ones, how to find the probabilities of this. There are a couple of like axioms, and we're going to use them. So property of property 1 is probability of E union F equal probability of E plus probability of F negative probability of E intersection F. Okay. Some people call this like inclusion exclusion principle. They can write that too. This also goes by inclusion exclusion principle. Okay. And this is goes by inclusion exclusion principle, and there is another like extension of it. So if E and F are mutually exclusive. Do you guys remember what mutually exclusive was from Monday? Any idea? Arsham, do you know what is mutually exclusive?
I'll be honest, I don't fully
Uh,
remember.
okay, it's all good. So mutually exclusive was like if they don't have any common element. Okay. So if E intersection F is this, or if we like to draw a picture like this, E and F. So they don't have any common element. Okay. Then if they do not have any common element, this also goes then gives a probability of E intersection F is gonna be 0. That just means like what is the probability of they like E and F having common elements? There are not any common elements. So the probability is 0. Does that make sense to you guys? Maybe. Okay. Okay, I'm gonna say like if this happens, if they are mutually exclusive and the probability of E intersection F is 0, then the extension of 1, then I'm gonna say extension of 1 is probability of E union F is probability of E plus probability of F, negative 0, since probability of E intersection F is 0. Okay, this is the extension. Okay. Any question? One thing you can do is like obviously write these formulas, okay, in your note cards. You'll have to remember these ones. Okay, let's see you guys are understanding this. Then let's talk about a problem 11.6 from the book. I'm gonna say suppose that the probability of an individual's eye color is probability of brown eyes is half, probability of blue eyes is 1/8, probability of green eyes is 3/8. Okay. Okay. Now, what is the probability of an individual to have blue or green eyes? Okay. So this is our problem. So I'm giving you the probabilities of brown, blue, and green eyes. This should be 3/8. And I'm asking you what should be the probability of an individual, blue or green. Okay. So what I can do is like I can write this as let E be blue eyes, the event, F be green eyes. Okay. Does that make sense to you? I'm just taking like two events. Okay. Okay. So from here, what I can tell you is like if someone has blue eyes, can they have like green eyes too?
I mean, technically, if we have
Like
heterochromia,
yeah, yeah, no, not that. Like so
okay,
by blue eyes, I mean like both of your eyes, like both of them are
yeah,
like yeah, yeah.
yeah,
Yeah, I
then
know
no.
what you're saying. No, not that, not that. Yeah. So technically you can, but here, like if you have blue eyes, you cannot have like green eyes, right? Or if you can have green eyes, you cannot have blue eyes. Does it make sense to you guys? Okay. Like you got that, like Artyom?
Yeah,
Okay. So I don't know if Alexis is still here. Alexis, are you still here? So I'm saying like if one have blue eyes, then the other one cannot have green eyes. So Alexis, can you tell me what should be E intersection F?
Um, is it 1/8 and 3/8?
No, those are like the individual ones. So I'm saying uh blue, if you have blue eyes, you cannot have green eyes. Or if you have green eyes, you cannot have blue eyes. So that means like they do not have what? Any common element, right? Or any
Oh,
common
so it'd be none.
empty. Yeah, it's gonna be empty. So probability of E intersection F would be 0. Okay, that's what I was saying here. Okay, that's what I was talking about up here. So now our task is to find probability of, it says like blue or green eyes. So probability of E union, because or means union. Remember that. Oops. E, this one, E union F. And we do know from this formula over here, probability of E union F is probability of E plus probability of F negative probability of E intersection F. So I'm going to write that. So this is from the formula. Okay. So this is the formula. Now, if this is the formula, then this part equals to 0. So it's just going to be probability of E plus probability of F. And probability of E means just blue eyes, which is 1/8. Probability of F means green eyes, which is 3/8. So it's going to be 4/8 or half the answer. Any questions for this? No questions. Okay. You guys are getting it, right? Hopefully. Arsim, did you get this or?
Oh yeah, I did.
Okay. Alexis, you okay with this or no?
Yeah, I'm good.
Okay, that's good. Okay. Okay, next property, okay? Probability of not an event. So probability of not an event, that means like probability of E bar is 1 negative of probability of E. Okay. Or probability of E, if I want to take that side, 1 negative probability of E complement. Same. This comes from here. Okay. So in some sense, like probability of E plus probability of E complement, they add up to 1. Okay. That's the property. And just for some brief explanation, if you draw the diagram like this, and this is your E, then I told you this thing, E complement, will be everything other than E, right? Now, if you also take E with it, that means probability of E, what color is this? Probability of E plus probability of E complement should be 1 because it kind of takes up the whole space. The blue is the complement one probability and the orange is the probability of E. So together they take up the whole rectangle, the whole sample space, because the rectangle represents the sample space. So if you add them, they should be equal to 1. So from there, from this equation, we actually get this. Probability of E complement is 1 negative probability of E. Okay. That's like the explanation. If you don't want to like understand it, that's okay, but you will need to know this line. Okay. Any questions? Okay. This is like a brief explanation of it. Let's solve a problem which you can use this not this property, okay? A family has 3 children. What is the probability? This problem can be solved in other ways too, but we're gonna show like, we're gonna use this like not E property. And sometimes this is easier for a probability problem. What is the probability that there is at least one girl among the 3 children? Okay. So this is the problem. We have 3 children and we need to find at least one girl among the 3 children. Okay. So first of all, for this problem, you can use, if you remember the problem we did with like purple flowers and white flowers, the pea plant problem, Mendel's plant problem. That is kind of similar to this problem too. And you can use this like the whole sample space, then find the ones that has like at least one girl in it. And that's gonna be the numerator, and the denominator, there will be like total number of outcomes. You can also do that. But here, what we're gonna do is we're gonna write, let E be at least one girl. Okay. So E is an event where you have at least one girl. Then what should be the E complement? Any idea? If event E is at least having at least one girl, then what should be the complement of it?
Would it be no girls?
Ashley, can you say that again? I didn't hear it.
Sorry, would it be no girls?
No girls. That means all the children are what?
Boy?
Yeah, exactly. No girls. Yeah. All right. This problem is like literally similar to that white purple flower and what white and purple flowers. Same logic. Okay, all boys. Now, if I want to find probability of E complement, it should be what? On the bottom, there should be the total number of outcomes. So as each child can be like either boy or girl. So what should be the total number of outcomes on the bottom? What should go here? Let me write it. Total number of outcome. Number of outcome in E complement. So it can be either a boy or a girl, right? So the first kid can be either boy or a girl. So 2 ways. The second one can be a boy and a girl. So another 2 ways. The third one, boy and a girl, another 2 ways. So what is the total number of outcome?
6.
2 times 2 times 2, it should be what, Ashley? Almost there.
8.
8, yeah, it should be 8. Okay, and all of them being boys, that's just only one outcome, if you can think about it. All of them are being boys. There is like no girls there. That's just a one outcome in the sample space. I'll still show you guys the sample space, okay? So on the top, it should be 1. 1 over 8. Okay. So what we're trying to find was, our goal was to find probability of E. Sorry, I'm gonna write this again. Probability of E, right? At least that was our goal. But what we found was probability of E complement. So from this one, the second one, from our property, what we can say is like probability of E equals to 1 negative probability of E complement, or 1 negative 1 over 8, or 7 over 8. That's our answer. Any questions? For this problem? No questions? Okay. I'm still gonna show you guys what I mean. Like, so if I wanted to draw a tree diagram of the children, it should be like this: boy, girl, as they have 3 of them: boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl. And as you can see, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 outcomes. And each of the outcomes is like this. One is boys, boy, boy, boy. So the sample space would be boy, 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 then boy, 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 girl. This one. So boy, 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 girl, then boy, girl, boy, boy, girl, boy, boy, girl, girl, boy, girl, girl. Okay. So you can see, like, if I write the whole sample space, only this is the only outcome which does not have any girls. And in all of them, there are at least one girl in the outcomes. So that is why, so I'm gonna write like dot, dot, dot here. That is why here we just had like 1 over 8. Does this make sense to you guys or not? Any questions? Ashton, do you have any questions?
Nope. I'm good.
Okay. So then property 3. Okay. I'm gonna write it here. Property 3. Probability of E minus F. So E minus F, we can write it like this. And we have showed like E minus F is also E intersection F complement or bar equals to P of E negative P of E intersection F. So this is another property. Okay. Then probability, another one, probability of not both events. I'll show you what I mean by this. That just means probability of E bar F bar 1 negative P intersection F. Okay. So that's like another example. Okay, let me write the other two once again, just to refresh your memories. Okay. The first one was probability of E intersection F was, sorry, E union F was this. So we have 4 of them. This is the first one. The second one was probability of E complement was 180 P of E. Okay, so 4 properties. Okay. Four properties. Okay. Now what I'm going to do, I'm going to try to solve a problem which uses all of them. Okay, all of them. So these are like the 4 properties that I have. The first one involves union of 2 events. Second one involves just complement of 1 event. The third one involves complement of 1 event and with the intersection of another event. The fourth one involves the complement of both of the events, E and F. Okay. Now, example 11.8. I'm just going to try to show you guys if, I don't know, how to use all of them in a single problem. Okay. A study in a tribe. So I want you guys to just like try to understand this. Okay. I'll post the class lecture. So if you want, you don't even have to write it down right now. America revealed. So this is revealed that 75% were blood type A and rest had blood type O. Okay. So 75% had blood type A, rest had blood type O. Okay. 60% were Rh negative and 30% were Rh positive and blood type A. Okay. It's a lot of things, a lot of information. Now, find the probabilities of type A and, sorry, or Rh positive. P is type A and Rh negative. Okay, at first we're gonna try to find these 2. There are like 4 of them, A, B, C, D. I don't know how much you can go through today. So I'm gonna try to find these 2 today. Okay, so for solution. So what's happening here is like we need to take 2 events. Okay, and there are like so many information. There are like 60% were Rh negative, 30% were Rh positive, and blood type A. So you can take Rh negative or Rh positive or blood type A or blood type O as your events. But what I'm going to do is, as this line says, 30% were Rh positive and blood type A. So from here, actually, I'm going to say A. So I'm going to just name it A, okay? A is type A, blood type A, and Rh positive. So that's another event is Rh positive. So I'm naming it like just the way it is. So if I want to draw a Venn diagram, this is how it should look like. A, RH positive. Okay. Okay, now I know it's a lot of information. So Ashley, if you're still there, do you know what should be the probability of A from the first line? 75% were blood type A, so it means what?
Yeah. Would it be 75% or?
Yeah, 0.75, right?
Okay.
Okay, and now if that is 0.75 and it says like rest had blood type O, right?
Yeah.
So that means like probability of blood type O is what?
0.25.
0.25, or I can also write this as probability of A complement, right? That means like O is also what is not in A, right?
Right.
Okay, thank you. Now, what else do you have? Probability of RH negative, right? Here, this line. Where is it? This line. 60% were RH negative. So probability of RH negative is 0.60, right? So Artyom, if you're still here.
Yeah, I'm there.
Okay, so can I write probability of RH negative is 0.60 or probability of RH positive complement 0.60? Will they mean the same?
Yes.
Yeah, right? Because
Mhm.
RH negative just means what is not in RH positive, right?
Yeah.
Okay, and then this should give you, what should be the probability of RH positive then?
0.4.
0.4, okay? Because it's just like what is left, right? 0.4, okay. Now, what else do you have? What else we have is 30%, the last line, the 30% were RH positive and blood type A, okay, together. So I can say from the last line, it's a lot of information, but we can like tackle them one by one. So if I take the intersection of them, RH positive and A, we're gonna get 0.30 from the last line, okay? Okay, these are all the information from the prompt. Okay, now the first one, I'm gonna take just one more minute, okay? Then I'm done. The first one says like find the type A or RH positive. So I'm saying A or RH positive because A means union, okay? So that's what we're trying to find. And this is should be from this formula over here, this one. So it's gonna be probability of A plus probability of RH positive, negative probability of A intersection RH positive. So probability of A is 0.75, probability of RH positive is 0.60, negative probability of A intersection RH positive is 0.30. You add them, you're gonna get 0.85. Okay. Do you guys have any questions on this?
Nope.
On this part? Okay. So as our time is almost over, I should have started this on the next class. I thought I can solve the whole thing. What we're gonna do, we're gonna go through this problem again on next class. And I'm telling you guys, this problem is like very, very important because this problem has like 4 parts. All the parts deals with one of the properties that I was writing to you. So this problem is very important. Okay. Okay. We are gonna talk about this on Monday.
So
Thank you. Yeah. So
basically, this problem is on the exam. Is what
maybe,
you're saying.
maybe, but you guys should go through this problem. I can say that if it's gonna be on the exam or not. But important problem. Okay. I'll see you guys on Monday, and hopefully you guys understood some parts of this problem. We're gonna go through this again. And thank you for being here. Have a nice day. We have a spring recess, so no classes on Friday. Have a good time. Chill, I guess.
Thank
Okay.
you.
Yeah.
Thank you. Have a good day.
You too.